Assalamualaikum and salam sejahtera to everyone. So for this week, me Alifah Ilyana and my partner Irenaeus will explain to you guys about our topic, which is energy metabolism. So for this topic, we will explain about 4 things that you guys should know. First of all, for my part, I will explain about energy metabolism and how energy is measured. And for the next part, my partner will take over and explain to you guys about how energy is released from the food and stored in the body, and how do we get energy from the body's energy stores. And my partner will use easy method for you guys to understand. So let's proceed to the first part in this topic, which is energy metabolism. What is energy metabolism? Energy metabolism is the sum of every single reaction that occurs of our body. For example, breathing oxygen from our lungs into vessels and then taking them to our tissues. This is a chemical reaction. Energy metabolism can be known as the process of generating energy, which is ATP, from nutrients. So for easy to remember, metabolism is all reaction that involves energy transformation. Metabolism are divided into 2 categories, which is catabolic and anabolic. What is catabolic and what is anabolic? Catabolic is something that releases energy and break down large molecules into smaller molecules. As we can see based on diagram that I have here, where the catabolic that use large molecules break down into smaller molecules and release the energy. Meanwhile, for anabolic is something that require input of the energy, and it also synthesis of larger energy storage molecules. As we can see based on the diagram that I already put in this slide, where anabolic, as we can see that anabolic is 2 things and 2 units together or joining synthesized. So for easy to us to understand the catabolic and anabolic, we can just remember the letter in front of the catabolic start from C. That means cut. I suggest remember catabolic as a cut because when cutting, things will breaking down. Meanwhile, for anabolic, we can remember of the letter of anabolic start from A. That mean add. I suggest remember anabolic as add, which also can known as adding or building. Next, I will explain about the chemical reaction of anabolic and catabolic. For example of anabolic reaction is reaction that use energy. Based on this slide, production of glycogen use energy by combining 2 glucose. Meanwhile, for catabolic reaction, as we know that catabolic reaction is reaction that release the energy. Okay, for example, breakdown of triglyceride into glycerol and fatty acid will release energy. How energy is measured? The energy in food that we eat is measured in unit of kilocalories or calories. First of all, how energy is measured in carbohydrates. Carbohydrates is a fundamental biochemical process that ensures a constant supply the energy of living cells. The most important carbohydrate is glucose, which can be broken down via glycolysis, enter into the Krebs cycles and oxidative phosphorylation to generate the ATP. Our muscles dependence on carbs during exercise is related to carbs availability, and our muscles will develop system from metabolism. Carbs will converted into glycogen glycogen storage, it was 40% in the liver and 60% in the skeletal muscles, and 1 grams of carbs is equal to 4 kilocalories energy. Second is fat. For your information, body stores more fat than carbs. Energy reserve from fats is higher than carbs. 1 gram fat equal to 9 kilocalories energy. In addition, fat is less accessible for cellular metabolism. Next, I will explain about energy measured in protein. Protein supply 5 to 10% of energy to sustain prolonged exercises. At the same time, 1 gram of protein is equal to 4 kilocalories energy. Basic unit of protein is AA, which is amino acid. Simple example of a measure of energy. As we can see, to get the answer of energy from fat, carbohydrate, and protein, is we should multiply the grams with energy per grams. The amount of grams of each energy source, fat, carbohydrates, and protein, and the amount of energy per grams of each energy source is given. Multiply the grams by the energy per grams to obtain the energy. Multiply in such a way that energy is on top and the grams are at bottom. It is because you want your final answer to be on kilocalories or calories. Okay, for example, I choose energy from fat. That the grams of fat was 11 grams multiplied with the units of energy per grams, which is 9 kilocalories per gram. So we get the answer 99 kilocalories equal to 99 calories.
Hello and salam sejahtera. My name is actually Irenaeus, and now I will continue what Alifah has been lecturing you in the first part in the course information up in the second chapter, which is energy metabolism. Okay, I want to ask for you guys, how many human energy system that has been classified in the basis of ability? Alright, the answer is, for you guys to know, they have 3 human energy system that has been classified in their basis of their ability and to release energy at the different rate of speed. Okay, what is this? Number 1 is ATP PCR system, and the second one is lactic acid, or well known as glycolytic system, and the last one is the oxygen energy system. Alright, for you guys to know, the ATP PCR system, also well known as phosphagent system, because both ATP and PCR contain the phosphate. What is ATP? ATP is also known as adenosine triphosphate, that immediate source of energy that's stored in muscle, and it will rapidly release the energy. The PCR is also high energy compound that found in the muscle that can help ATP rapidly as it be used, and the energy release when the PCR split is used to form the ATP from ADP to P, and PC is used also shortly supply and needs to be replenished in if it has been used. Alright, for the last part, which is about the oxidation of carbohydrate, I already choose one of the video from the YouTube that talking about the oxidation of carbohydrate, which is content 3 part, which is about the glycolysis, Krebs cycle, and also the last one is the electron transport change. Hopefully you all can understand it because it was easy to understand, because it was simple, and because I also used that video as my sample because it was when we talk into the slide, because it was too complex, but when we watched this video, it was very simple. All right, I will show you the video.
Respiration and the 3 parts. We'll look into the reactants, the products, other products, as well as the number of ATP that we make in an entire cycle of cellular respiration. We start with C6H12O6. It looks like a super long name, but essentially all that is glucose. Glucose plus oxygen will result in the production of carbon dioxide, water, and energy in the form of ATP. I've listed up here the 6 things that we'll take a look at. We'll look at the type of step of cellular respiration, 1 of 3. We'll look at where it takes place within a cell. We'll take a little look at the reactants, so what goes in, the input, and we'll also examine the main products as well as byproducts that are produced during this reaction. At the very end, we'll take a look at the number of ATP and then take an entire summary for how much ATP we've made in total. The first step of cellular respiration is glycolysis. The place that glycolysis takes place is within the cytoplasm. So I'll put up an image of a cell and I'll show you guys exactly where glycolysis occurs. So here's my cell. I'll draw in a nucleus as well as a nucleolus. You can also imagine the endoplasmic reticulum, and I'll put in a very large mitochondria. So this is very important. Step number 1, glycolysis occurs in the cytoplasm. Great, so what goes into glycolysis? As you can probably figure out from the name, glycolysis literally means cleaving or cutting a simple sugar. So the sugar that we are cutting in this case is glucose. Glycolysis, lysis meaning splitting. So we're splitting up a sugar, or more specifically, glucose. This process is anaerobic, which means we do not require the presence of oxygen. The major product of glycolysis is a molecule known as pyruvate. While glucose is a molecule with 6 carbons, pyruvate only has 3 carbons, which means that a 6-carbon glucose can be broken down into 2 3-carbon pyruvate molecules. And during this reaction in which glucose becomes 2 molecules of pyruvate, there are no really major byproducts that we produce. However, we will yield some ATP. Unfortunately, glycolysis doesn't result in a lot of ATP, which means we can't perform glycolysis for too long or rely on it too much for our source of energy. And the reason for that is because glycolysis only produces 2 molecules of ATP. 2 molecules of ATP is really not a lot, which is why we need to perform various other steps during cellular respiration to give us the energy that we need to carry out our daily lives. The second step of cellular respiration no longer occurs in the cytoplasm. Instead, the 2 molecules of pyruvate that we just produced will move on somewhere else. So what will happen to the 2 molecules of pyruvate? They actually move from the cytoplasm directly into the mitochondria after a series of modifications. As soon as pyruvate moves into the mitochondria, we can begin the second step, which is known as the citric acid cycle. You may also see the citric acid cycle written as TCA, which stands for tricarboxylic acid cycle, or the Krebs cycle. Again, the Krebs cycle, or the citric acid cycle, does not take place in the cytoplasm anymore. We've moved on from the cytoplasm into the powerhouse of the cell, which you may remember is the mitochondria. The two molecules of pyruvate that we produced during glycolysis will then move on to be the reactants of our next reaction. As a result of the Krebs cycle, pyruvate will become a product. In this case, pyruvate will turn into some high-energy electron carriers. You may see these high-energy electron carriers written as NADH and FADH2. You might also see them written as high-energy electrons or electron carriers. I'll call them here high-energy electron carriers and make a note that you might also see them as NADH or FADH2. Again, in the mitochondria, pyruvate turns into these high-energy electrons. The byproduct of this reaction is carbon dioxide. Remember, when humans are breathing, we're eating sugar and breathing in oxygen. We always exhale carbon dioxide as a waste product. If anyone ever asks you where that carbon dioxide comes from, you'll know that the step in which this occurs is the Krebs cycle or the citric acid cycle. Carbon dioxide gas is a byproduct of this reaction, where pyruvate becomes these electron carriers. During the Krebs cycle, the number of ATP that we produce is still not a lot. It's not enough to power the reactions of daily life. Unfortunately, the Krebs cycle is only able to provide us with 2 molecules of ATP. The third and final step of cellular respiration continues in the mitochondria. We're still in the mitochondria, and we are going to use this time the high-energy electron carriers to produce our product. If in the mitochondria we have these high-energy electron carriers bringing electrons down a chain, and the only logical name for the system or the step in cellular respiration is the electron transport chain. Because what are we doing? We are moving these electrons from very low electronegativity down from carrier to carrier until our very last carrier is extremely electronegative. That's why it's chain. The main product of this reaction, unlike being an intermediate, is actually ATP. So all of this was done with the goal, the intention of producing a ton of ATP through the electron transport chain. As for the byproducts, I pointed out earlier that in the electron transport chain, we're pulling the electrons to carriers with increasing electronegativity. You might remember from chemistry class that the most electronegative atom that we look at in this reaction is oxygen. Oxygen is the final electron acceptor. When it accepts the electrons, it also accepts 2 protons or 2 hydrogen ions. When this happens, you have an oxygen and 2 hydrogens, you produce water. The water is the same water that we exhale in the form of water vapor with every single breath. So whenever we perform cellular respiration, we are exhaling carbon dioxide and water, which come from the Krebs cycle and the ETC. Most importantly, the number of ATP that we produce in this final step clearly outweighs the ATP that we produced before. During the electron transport chain, we produce an amazing 28 molecules of ATP. Some sources that you see may say that you are producing 30 or 32 ATP molecules, and the answer is it really does depend. It depends on whether you are using NADH or FADH2. It depends on the high energy electron carriers that are involved in the reaction. For the most part, however, you will see 28 ATP. Ultimately, we have 2 ATP produced in glycolysis from the cytoplasm. There's 2 ATP produced in the Krebs cycle, which happened in the mitochondria. And finally, 28 or 30 ATP produced as well in the mitochondria through the electron transport chain. In the end, we have 2 plus 2 plus 28, which gives us a total of 32 ATP. Let's do a full recap of cellular respiration. First of all, there's 3 steps. We have glycolysis, the Krebs cycle or the citric acid cycle, followed by step 3, which is the electron transport chain. First, we started in the cytoplasm for glycolysis, where we went from glucose into 2 molecules of pyruvate. The pyruvate turned into high-energy electron carriers, and this step happened in the mitochondria. There was some ATP produced during both reactions. Finally, these high-energy electron carriers performed a very important step in which 28 molecules of ATP were produced. And as well, during this reaction, we have a byproduct, which is water. We moved from the cytoplasm into the mitochondria, and we began with glucose, and we ended with a ton of ATP. That's the whole goal of cellular respiration, is to go from our glucose into energy. And that's exactly how we did it. So we had 1 molecule of glucose, and it gave us in the end 32 molecules of ATP, or energy. I hope this video was very helpful for you guys. If you have any questions, feel free to come see me in my office, or we can also communicate through email. Thanks for watching, and if you have any other video ideas, don't hesitate to let me know. I love making videos. Thanks, guys.